Another video in our series. We are still working on the January 2024 paper, and we are at question 5. The question 5 on this year's paper is a statistics question, and so we'll go through it, and I hope that at the end of this video that you would have learned something, or if you have learned something, that it will reinforce what you already know. So let's go. It says the mass in kilograms of 120 newborns at a hospital is recorded in the table below. So the mass in kilograms is so the groups are on the left and the frequency are on the right. So we have 2.6 to 3.5, we have 7. Between 3.5 greater than 3.5 to 4.4 is 18. Greater than 4.4 to 5.3 kilograms is 30. Greater than 5.3 to 6.2 is 29. And greater than 6.2 to 7.1 is 28. And greater than 7.1 to 8 is 80. Is 8. To 8 kilograms. I assume that is 8. It says 80, but I'm sure that is supposed to be 80 kilograms. 8 kilograms rather than 80. Yes. So what they want to know, state the modal class. So the mode in statistics, there are three central tendencies that we can use to analyze statistical data. We have mode, median, and mean, arithmetic mean. In this case, they're asking for the modal class. So therefore, in order for us to determine which one occurs the most, we have to look at the frequency. So if we look at the frequency here, it's 30, so 30 is the highest. So therefore, the modal class is between 4.4 to 5.3. So this is the modal class here. So that's a modal class there. So what the modal class is telling you, that this is a class that most of the babies were born. That's greater than 4.4, but less than or equal to 5.3. Next, so move on to the next question. So we are to fill in the blank spaces here, and then filling in the blank spaces, we first want to know what the midpoint of each of these of the missing areas are, and we also want to fill in that area as well, the ones of the frequency times the midpoint. So in order to get the midpoint, we are going to add. So for each class, we add 5.3 plus 6.2, and then we divide all of that by 2. So that's how we go about getting the midpoint, and we would have got 5.75. And so to get the frequency times the midpoint, we're going to multiply 5.75 times 29. So we'll multiply this 5.75 times 29, and we are going to get 166.75. So that's how you would have got that. Now, in the other one, 7.1 to 8.0. No. So again, we add these two, so it's 7.1 plus 8.0, and we divide that by 2. That's 15.1 divided by 2. 15.1 divided by 2, and we are going to end up with 7.55. Now, so in order to get the frequency times the midpoint, we multiply 8 times 7.55, and we would have got 60.4. So that's how we would have gone ahead to do those two questions. Again, this is something that you are able to do, so please do not doubt your own abilities. Just remember to practice as much as you possibly can, so that you can do well in your exams. Okay? All right. So the next part of, so moving on to the next part of the question. Now, one newborn is chosen at random from the hospital. Find the probability that the newborn has a mass of greater than 5.3. So if we go back 5.3 kilograms. So if we go back, so all the masses that were greater than 5.3 are these numbers here. So these are numbers that are greater than 5.3. And so what we're going to do, we're going to add as a mass greater than 5.3 kilograms. So therefore, yes, so we had looked at, so we recognize that the mass is greater than 5.3 were 29 plus 28 plus 8, and that gives us a total of 65. Okay, now whenever we're finding probability of, say, so we're looking at probability greater than 5.3, what we are going to look at is the number of possible, so it's number of possible outcome divide by the total. All right, so the number of possible outcome here is 65 because only 65 were greater than 5.3, and the total in the sample was 120. So when we divide that, we get 0.54 to 2 places of decimal. All right, so that's how we would have done a question like that. Now, so we are now to complete the cumulative frequency. Now, so the cumulative frequency, as the term cumulates, when you accumulate something over a period of time, it adds up. So basically what they are asking you to do is to just look back at the table, and then we're going to keep adding as we go along. So it was 7, and this between 5.3 and 4.4 was 3.5 and 4.4 was 18. 18 and 7 will give you 25. And then we keep adding. So what we're going to add here is 29. So 29, so we're going to add 29, so we can go back to the table. So 84, okay, 84. And then we're going to add 28. 28 plus 84 will give us, so we're going to add 28 to this number here. So 84 plus 28, 8 and 4 is 12. 8 and 2, 10 and 1, 11. So we get 112. And then we're going to add 8 here. 112 plus 8 will give us 112 plus 8 will give us 120. And that's our cumulative frequency. And that's how we would have gone ahead to calculate the cumulative frequency. So in order to get the cumulative frequency, we just add the numbers for each group as we come down, as we progress downwards. All right? So that's how you would have done that one. Next, so we are now to put this on a graph. Okay? So what they have done so far, they have done 2 of those. They have done 2 for you. So they have done this one and they have done this one. So we are to now continue. Continue. So the other one was 5.3. So if this is 4.5, this is one is 5. So 5.3 would be the third one, right? So 5.3 plus 5.1, 5.1, 5.2, 5.3, 5.4, 5.5. So each of these will represent 0.1, okay? And 5.3 corresponded to 53. So this is 50 here, 50, 50, 50, 52. So 53 would be halfway. How we know that? Because each of these is each of the stroke here is 2. So 52, 54, 56, 58, 60. So 53, 55 rather. 55 would be in between 56 and 54, and this is 5 point. So this one is 5.3. Just be patient with me, please. So there. So this is 54. So that one would be 5.5. So because again, this is 54, 52, 54, 55, 56. Okay, let's move on. So 6.2. So this is 6.2 would correspond to 64. So 60, 60, 62, 64, and 6.2 would correspond to that one. So that's our line there. And next one, 7.1. Oh, sorry. So now they want us to construct the cumulative frequency curve from this information that they gave us here. So we know that 5.3 corresponds to 55. So this is 5. So 5.3 corresponds to 55. So 52, 54, 55. So all right, so that would be 55. And then now we have 6.2. So here we have 6. So this one represents 6. So 6.2 corresponds to 64. So 6.2, so 6.1, 6.2, 62, 64. So there we have 6.2 corresponding to 64. Then we have 7.1 correspond to 112. So we have 7. So this one represents 7, and that corresponds to 112. So 112 is here. So here we have 110, 112, and so we have that there. And then we have 80. 8.0 correspond to 120. So 8.0 correspond to 120. And that we have. And now we are to complete the cumulative frequency curve. And that's our cumulative frequency curve. Now, the next part is going to ask us to estimate what the mean is. Now, the mean corresponds to the mean, or the median rather, the median corresponds to to 50% of the ogive, and the ogive is called the cumulative curve. All right, having now drawn your ogive or your cumulative curve, you are now asked to estimate the median mass of the newborn. So here we are asked to estimate the median mass of the newborn. Okay, so the median corresponds to 50%. Is that mass that corresponds to 50% of the cumulative frequency. Now, so the total of the cumulative frequency, so the median corresponds with 50% of cumulative frequency. Okay, so basically it's that mass that corresponds to 50%. So 50% of the total, so we want to find 50% of 120, and that gives you what? 50% is the same as half. So that means it's any number that corresponds with this number here, 60. So we find 60, we go across. When it touches the ogive, we come down and this mass down here is a mass that would be the median. So the median in this case, is equal to 5.5 kilograms. Now, the accuracy of this value will be dependent on how neatly you draw your graph. As you can see, my graph is not that very neat. But what we can understand is the basic concept. That's how you go about finding the median, whether it is 100 or 120. Again, what we want to do is to find 50% of this total. So 50% of 120, 50% of 120 is equal to 60. So whatever this value is, you find 50% of that, and then that value that corresponds with this would be equal to what? The median. And so this is how you go about solving these statistics question. Again, statistics is one of those questions that are very popular, that is very popular on the CXC paper. So therefore, it's important that you get a lot of practice on statistics, so that whenever these questions come, you'll be able to do them. Okay, have a great and wonderful day.